Alright everyone, so let's look at 6.2. 6.2 deals with inverse functions and relations. Now, inverse relations, which are not necessarily functions, finite set of points, finite set of numbers, we know that those are inverses, if and only if, they contain essentially the same elements in both, however the x's and y's are swapped. So for example, like we have relation G here is 1, 5, 2, 6, 3, 7. Relation H is 5, 1, 6, 2, 7, 3. Notice how they've got the same elements paired the same way, just the order switched. If that is true, you've got an inverse. Or if I had to find the inverse of, say, G, all I would do is just switch my x and y. So I would say, okay, I've got 1, 5, so I have 5, 1, and so on. So sometimes you might be just identifying, hey, is this an inverse? Sometimes you might actually be finding the inverse. Now, we can't let inverses just go for relations. They do exist for functions, however, not all of them, or at least not all of them will be functions in the end still. So if you have the graph, which is one way to tell whether your inverse is a function or not, if it fails the horizontal line test, then our inverse is not a function. However, if it passes the horizontal line test, our inverse is a function. And you won't come across these too often, but sometimes, say I had, just a function like that, and I'm just asking you, hey, is the inverse a function? Instead of going through and doing the math, which we're about to look at, you could just be like, well, nope, not a function, move on. So that's a quick visual way of knowing whether or not the inverse of a function is also a function. Similar to how we did the vertical line test to test if that original function is a function. Horizontal line test does that for us for inverses. Now, finding inverses. We typically do this mathematically. We don't always have the graph and then reflect it over. What you end up doing is reflecting it over the y and y equals x. So the way we do this, we write or rewrite the function as an equation with just x and y. So I see this function. It's in function notation, so I'm going to make that y equals 2x minus 5 instead. Switch the x and the y. Just the variable. That 2 is not coming with the x. So all I have here is x equals 2y minus 5. Now, that should look a little weird to us. We have x equals something. That would be great if we were doing substitution with systems, but we're not. So we just solve for y. Get everything away from y just as if you would do if you were solving for x or any other variable. So I see I've got that minus 5, so I'm going to add 5 to both sides. At this point, the only thing left with that y is the 2, so I'll divide both sides by 2. And my final answer is y equals x plus 5 divided by 2. That is my inverse of that function. All you do, write it as a function of x and y, and do rewrite this step even if maybe there was a y in there originally. Write it out for yourself just so you can see, okay, I'm moving this x to be here and this y to be here, and then solve for y. Don't try to do it all in your head. You know I'm looking for work anyway. Now, if I ask you to verify inverses, keyword verify, you can't just find the inverse of one of them and see if it matches the other. You absolutely must find the composition in both directions, so in other words like f of g of x and then also g of f of x, and see that they both equal x. If they both equal x, they are inverses. If the first one you plug in and it doesn't equal x, you don't have inverses. You can stop and say, nope, not inverses, and move on. But if one of them works, you do have to check that that other direction works as well. So, if I was determining whether these were inverse functions, I am finding both f of g of x as well as g of f of x. So remember the way that we do these, whichever one is closer, that's the one that gets plugged in for the other one. So see, this is g of x. So I want to find the function of g of x. I want to plug in g of x anywhere I have that x in f of x. So I start writing out f. I've got 3/4 x. Oh, I see an x. I've got to plug in my other function. And then I got to make sure I finish off the rest of my equation. If you make a silly mistake, chances are it'll be that, if it's not a mathematical one. So I multiply through. Chances are if you have fractions, they do work out nicely like this, so don't worry about it. And then we get x plus 6 minus 6. Well, that's just x. Great. We do have to check the other way. Sometimes it'll work one way and won't work the other. Sometimes neither of them will work. Sometimes they both will work. You have to see what's happening. So we check the other way. So I want g of f of x now. Notice how this is that f of x. Anywhere I see an x in g, I'm plugging in whatever that function of f is. So I start writing out g, 4/3. Hey, I run into an x. I plug in that f of x function. I make sure I finish writing g. That plus 8 is important. Without it, we would just end up with x minus 8, and we don't want that. So, again, my fractions simplify nicely. I end up with x in the end. Because these both equal x, these functions are inverses. Again, you cannot just go, oh, I'm going to switch x and y, and I'm just going to find the inverse for this one. If it matches the other one, I'm okay. You won't get any points for that. No points. You need to do the composition in both directions. And like I said, if you have fractions, typically it works out nicely. So that's all I wanted to cover for 6.2. We'll briefly touch on anything else that I want to talk about, particularly domain and range with these guys in class, and we'll go from there.